Hey guys, welcome to LeetCode. Today we're going to solve a very easy algorithmic problem called two-sum. So this type of question you usually see it on technical screening, but without further pausing, let's just go to the code. Given an array of integer nums and integer target, return indices of two numbers such that they add up to the target. You may assume that there is exactly one solution here. So let's look at the example that has been given to us, 2, 7, 11, 15, and we want to see which elements would add to 9. So easily you know that, for example, 2 and 7 can add to 9. Second one, we have 3, 2, 4, and then we're looking at 6. So we know that 2 and 4 are the indexes 0, 1, 2. So we're returning 1 and 2. And then here we have 3 and 3, so we return 0 and 1. So this is a very easy problem, but the only thing we need to always have in mind that if you are going to write the optimum solution, we want to avoid scanning the whole array, entire array one to one. So whenever something like two for loops or like inner nested loops comes to your mind, please find a way that you can optimize that so you somehow use memorizations and in order to optimize your algorithm. In this case, we're going to have a one pointer that scans the entire array, and we know that what is our target, and we are going to define a variable called complement that will say if we have that complement, that means that we found our case that they add up to the target. And complement means target minus num. So in this case, if we are looking at 2, our complement is 7. And then, so we start actually scanning the entire array. And if we don't find the complement, we will write whatever we have into memory. And then we always refer back to our memory without the need to scan the array again. So in this case, we start by 2. We define the complement as 9 minus 2 is 7. We don't have 7, so let's just write 2 inside our array. So say we saw 2 at index of 0, and then we go to the next one. In here, say we are at 7, but what is the complement? The complement would be 9 minus 7, that means 2. Have we seen 2 in our memory so far? And the returned answer is yes, we saw 2 at 0, and then we'll say, okay, we are at index 1, let's just return index 0 and index 1 together because we found our solution. Very easy. Let's just implement it inside the code. So in here, I'm going to say, let's define a variable called scene, and then as we declared, so we're going to say it's an integer dictionary. Uh, I'm writing in Swift language, so you can write it in any language that you want, but pretty much syntaxes are similar. So I'll say for num, for index and num in nums dot enumerated. So it's just give us the index and the number for every item inside the array. And I'll say let's complement equals to targets minus the number that you saw, and then we look for, say, if um, complement index equals to, have you seen it? Was it inside the scene yet? And say scene of the complement. Have we seen this number inside our dictionary? And then if yes, the complement index would contain that. So say return comp. So we are returning an array comp index and the current index that we are at. And then if not, let's just add it to the dictionary. So say scene we saw number at this index. And that's it. And then because we have to satisfy the compiler, we're going to say, in case you didn't finish your whatever you're going to find, let's just return -1 and -1. Um, Sorry, we need to define the iflet. And yep, as you can see, and yes, we're going to submit this, and we can see our solution was pretty much very good in performance. So for runtime complexity, we look at the algorithm and we see we have a for loop that has the iteration of n times, and n equals the number of items inside this array. And in here, we're looking up the numbers inside the scene. So lookup inside the hash maps usually is O of 1. So n times 1 is n. And we say the runtime complexity of this algorithm is n. For the space complexity, we are storing all the informations of the previous nums that we saw, and technically this can grow as big as nums minus 1 if you know that there, the algorithm guarantees that there is one answer. So we have stored all n minus 1 there. So we'll say n potentially is the maximum size of the scene, and in this case our space complexity would be O of n as well, which n means number of elements inside our array. That's it guys for today. Thanks for watching the video, and please don't forget to like and subscribe. And if you have any other problems that you want me to review in this YouTube channel, please put that in a comment and I'll make sure to answer all the comments as soon as I can. Thank you. Peace.